Thank you very much for having me. This is actually my first time speaking at Hack Soho, but I've attended many over the years. So thank you very much, Gav, wherever you are, for the invite. There he is. Thank you for the invite. So my name is Max. I'm the founder of Secure Agentics, where we are building the security products that everyone in this room who has a cyber background knows that AI demands. And today we're going to talk about agentic AI in the wild, and we're talking about risks, reality, and a framework which I've created for survival. Before we get into that, though, a little bit about myself and why I'm here and talking to you guys about this. I'm a principal cybersecurity consultant. I've got over 6 years experience. I started, actually, another shout out to Gav, my first ever job in cyber, which was working with him. And that was 6 years ago in pen testing, and then moved more into the red teaming side of things, and then worked my way up and was leading red teams. In that, I've sort of built and scaled red teams, done security research, and have spoken at a number of different conferences on the different research topics that I've got within that. And as well, in the last sort of, I would say, year and a half, I kind of saw the opportunity that AI was the area which I thought is going to require a lot of people with a lot of security background to focus on. And so I said, right, that's the area that I'm going to focus on now. And so for the last year and a half, really, I've been kind of completely obsessed with AI security. I've got a newsletter which you'll see littered all throughout this with different QR codes, where I post in almost weekly. I've been a little bit lax recently because it's been kind of mental, but almost weekly updates on what's happening in the AI security space. But then on my actual day job side of things, I've been doing work with a number of different AI startups, helping them do secure by design, actually following the framework which we're talking about today. But then also doing a lot of AI pen testing, working a lot with the UK central government, and also high street banks through the years of working with these sorts of organizations over time, and then now focusing on AI, and obviously that's the hot space to be. I do a lot of research as well myself into the space, following what's the latest trends. There's a lot of stuff which is very exciting, and it's kind of moving at pace. And if anyone, we'll talk about it later on, but if anyone's seen the recent research from AISI or AC and the Alan Turing Institute and Anthropic around the data poisoning, you'll see that like any given week in AI security, things can change quite dramatically. So keeping on top of what's going on there as well. So before we get too far into this, I've already said it a load of times, and it's worth clarifying and making sure everyone's on the same page with regards to what actually an AI agent is. Now, I'm hoping by this point in the journey, everyone is somewhat familiar, at least, with what an AI model is, or an LLM, as we mostly call them, which is generally, if you're going to kind of compare it or think of it as, it's the idea of having a turn and response with an AI system. So you ask a question, which is the most typical way that we interact with them, and you get a response back. Really, under the hood, an AI agent does the same thing in that it has an LLM, which is kind of under the hood and running with it. But what we've now done is this next iteration of AI is to also give it tools and the ability to interact with the external world. I'm going to try and stand quite off to the side here so I don't actually block what I'm trying to talk in front of. And let it interact with the real world and give it autonomy. And that's really where the agentic or agent side of things, because we're giving it agency and the ability to make decisions and to interact with the external world, which is brilliant. And the journey of AI agents over the last few years has been rapid and actually quite fascinating. So this is paraphrasing and summarizing, but in roughly sort of year 2023, that's when they started sort of first rearing their head in the sort of opportunity of what an AI is. I mean, if you think of it as, think of all the things that an LLM is good at doing or is knowledgeable on, and then think if you could empower the LLM to take actions on your behalf, how powerful that could be. I mean, my background prior to AI was entirely in cloud security and in red teaming in cloud environments. And I was turning to AI to understand all the different Azure permissions time and time again. And it was not that far off saying, okay, well, actually, what if I allowed it to run the checks myself, right? That's the idea. And the most crystal example would be if instead of in a traditional GenAI environment, you say, oh, I want to ask what flights there are between here and New York on Monday, you hand over the reins and you say, book my flights to New York. That's the difference between what we've seen before with sort of GenAI and now agentic AI. And the use cases for agentic AI are almost as varied as the use cases of what we now think of and use AI for into the modern age. You probably can't see it here, but really there's sort of no end to what you could connect an AI agent to, which we'll talk about a little bit more. Under the hood, as I said, they're LLMs that are then connected to these tools, which allow them to do things on our behalf. Now, this is the first plug, or well, I say plug, it's anything which I'm talking about and has a QR code. I've covered it in depth in an individual blog, right? So if you see these dotted around on any individual slide, that's because that's where I kind of covered that a little bit more. So with a clear understanding of what GenAI is and what agentic AI is, let's talk a little bit about the attack surface and where things can actually go wrong. And this is where you'll be very glad to know that everything that exists with traditional GenAI exists in terms of the risk and attack surface, exists in agentic AI, but there's really good news in that it's much worse when it goes wrong in agentic AI, and there's more things that can go wrong. So what are the things that we're kind of looking at here at the moment? Well, traditional GenAI has suffered from a number of things. There's actually, after this week, literally, I would put an additional one in here, which is data poisoning. But hallucinations, we all know that AI is not perfect. In fact, AI, all it ever tries to do is give you the best effort answer as to what it thinks the answer of a question is. And most of the time it's right, and most of the time we can trust it. But sometimes it completely trusts itself on something which is actually completely false. And that's where we get the idea of hallucinations. Biases. So, for example, when you're using training data that comes from a certain area and then, or certain, has biases in the training data itself, then in a Gen AI world, then maybe that is problematic. It certainly can be, but in an agentic world, let's say you're using that to filter CVs, for example, the biases which are inherent to the training data then become actually now potentially turning people away from jobs. So again, this idea of autonomy, giving autonomy, these same problems become much worse. Prompt injection, I'm assuming here everyone knows about prompt injection. So all I will say on the topic of prompt injection is that it's much, much worse when you're connecting it to an agentic system, which can then actually do things on your behalf, because that's where you're empowering the tool to take actions. And if you can misalign that LLM, then there's any number of different things that can go wrong. The other one as well, which I would now say is it should be added to that, is data poisoning. I hinted at the research earlier, but if you're not familiar, it was literally this week, I think. The AI Security Institute, Alan Turing Institute, and Anthropic challenged the assumption that you need a significant portion of data in the training data to be poisoned for that to poison the model itself. And they said that was 1%, or the general understanding prior to this was it was 1% of the data needed to be poisoned, which, when you're talking about the scale of data sets that we're talking about, is actually a lot of the data that needs to be poisoned. What they found was, in the worst case, it was 0.00016% of the data that needed to be poisoned for the actual model itself to become poisoned as well. So that's exciting and challenging. But now we've got the fact that whenever any of these go wrong, you're not just getting a malicious answer or perhaps saying something malicious about a company or a competitor. You're actually taking actions in the real world. And this is where the impact of this becomes much higher. And also, and another thing which we'll talk about a little bit more when we come to the framework side of things, is that we've also got the agents are just doing things that we don't expect. One of the interesting scenarios here is that we're putting agents into unpredictable sort of operating environments where they're conditions we didn't expect or anticipate, and suddenly they do things that we had no expectation they were going to do. And the idea of a technology completely going quote unquote rogue is something that maybe we've had to deal with in certain technologies, but it's definitely not something that we're dealing with at the scale that we've got now. And so ultimately, when you sort of combine all of this, you're at the state where we've got a new and untrusted technology that has existential problems in the security makeup of it. So let's look at data poisoning, prompt injection, hallucination. With Gen AI, we're rolling this out at scale, which is already somewhat problematic. And I'm sure a lot of people here will feel the pain of when security is lagging way behind the adoption side of things. But then not only that, we're now adding in the agentic layer, which says, let's actually trust this to take actions on our behalf, and let's make this 10 times worse if it goes wrong. So you can see when you add it all together, the sort of picture we're at. Now, there's a video which, oh God, I have to move. which the blog I talked about, you'll be able to see it more there, is from Jason Haddix, which I'm sure everyone here knows. And he's in a talk with Network Chuck, who's a YouTuber that I actually watch quite a lot and I think is brilliant. And they, I don't know, he said me too, but I respect that. And they had a video where Jason Haddix was talking about the current state of AI security, and his best comparison was it's like web back in the day when there was SQL injection everywhere and no one knew how to code securely. I could not agree more. There has not been a AI system that I've pen tested which I cannot jailbreak, and that's not a flex. That's the state of AI security right now. And so we're sort of in this rapid adoption, security sort of somewhere trailing behind. We're not really sure. New threats, perfect example with data poisoning coming in this week. And what that essentially means is that we're seeing a lot of breaking headlines of agentic incidents. Now, there's 3 that will come up here. That's from Amazon, Google, and Replit. And all 3 of these happened in a single week last month of how AI agents are currently being used and how they're being abused. This one was from Amazon Q. Amazon Q is a coding assistant. And essentially what happened was the attacker pushed a malicious code change request to the GitHub, which was actually accepted. So it was a fail in the human controls side of things, which already was a big problem. It was then pushed out to all customers who are using Amazon Q. And there was code in there which basically said, if you are an agent and you read this essentially, then wipe the device that you're running on. And this was pushed out to all of Amazon's customers. The only reason why people don't know more about this is because there was a syntax error in the command, which meant that it didn't run properly. However, the idea here is that we're already seeing people are using this technology and abusing this technology. Gemini CLI as well had the same thing, where people found that if you put malicious instructions in a README file, it just forgot about all of its security training and security guardrails. And then the worst of the lot is Replit, which is a coding company that do sort of low code, no code, vibe code style product development for you. And one of their agents, for no good reason, just wiped the entire production database during a code freeze and then lied about it. So if you're talking about like a technology risk that we don't quite understand or have ever seen before, you're kind of looking at it here with what the problem statement is. If you want to cover those in more detail, those 3 breaches, that's the link there. As a result, then, we are seeing regulators scrambling, being like, okay, we need to start putting a lot more control in here around how we are going to secure these AI systems. So ISO 42001 is coming out, the EU AI Act is coming out. All of this is sort of like in the stage of coming into fruition, I would say. Right now, there's no sort of blanket GDPR style, like everyone must adhere to this in the UK. The NCSC's guidance for secure guideline development as well as the Department of Science, Innovation and Technology, who's a government department who set the technical standards for the rest of the UK Gov. I work with them on their AI side of things, and they have already got to the point where they are pushing out a code of practice because they don't want UK Gov falling foul of a lot of this stuff. Which brings us on to DAMSIC. And DAMSIC is the framework that I have made to allow us to think about all the things we need to think about. And really, DAMSIC was born out of essentially reverse engineering every bit of guidance, which I just mentioned through NCSC guidelines, ISO, through all of the other areas that I just talked about, as well as delivering my own pen testing work in AI, as well as advising companies in AI secure development, as well as reading up on what the latest trends are and threats are. And so essentially what I wanted DAMSIC to be was at the highest level a all in one place framework where you're like, okay, if I'm thinking about incorporating AI internally, what are at least the buckets of things that I need to be aware of when I'm thinking about security? And now any individual one of these could be a whole nother, talk. And I'm working with startups right now to implement this in their code. And actually there's a lot that goes beyond more into the kind of nuances of this. But the idea here is that you get the buckets of things to be thinking about. So DAMSIC is the name. It's data privacy, autonomous security, monitoring and red teaming, supply chain and SBOM, model integrity compliance, DAMSIC. Altogether, DAMSIC, so it's got a nice, easy way of remembering it. So I will now proceed to go through DAMSIC, and then we can have a chat about it at the end, and we can talk about it a little bit more. So number one, data privacy. It's very much worth saying that when you use AI, you are sending that data off and losing control of it. The number of organizations I speak to who don't realize that and are sending off their financial data, their client data, and not really understanding that actually they're sending that data off, and it's kind of, if you're using vanilla, let's say ChatGPT, and you've not got any contractual agreements in place or anything like that, then that data is generally, you're accepting that that's going to get locked into the training data, which means that's really lost forever. There's no way of getting that back. So first and foremost, it's worth saying that that's what happens when you're using AI in its most basic form. And from my experience working with sort of C&I clients, there's a handful, there's basically a maturity path, which most people follow and is applicable and works for a lot of people. The first one I mentioned is direct, I'm using API here, but you can just refer to this as direct interaction with the AI provider, vanilla, when you use ChatGPT in your browser example. The next version up from that is that you have a contract with whoever it is. And once I don't know exactly because I've not done the contracts myself, but I work with a number of people who've done those contracts. I don't know what bar you need to surpass, if they'll do it with anyone, or if you need to be spending a certain amount with them. But generally speaking, these companies will offer you a corporate contract which says in writing that you will not use our data for training, you will not store our data, you will not do any number of different potentially malicious things. There's also, on top of that, the next version up, which is that you don't just trust their word, but you actually scrub the sensitive data at the firewall or at the gateway that leaves your environment. You scrub the data there to make sure that any specific identifiers and client-specific terms have been removed because you don't trust them, which we probably shouldn't. The one which we're doing at Secure Agentics, and that which I genuinely find actually is quite a nice middle ground, is using something like what we call an AI managed service. So the two main ones in this space are AWS and Azure, and they are called Bedrock for AWS and Azure OpenAI. What these essentially allow you to do is to interact with frontier models. So obviously with Azure OpenAI, you get access to the OpenAI models and the latest and the greatest frontier models. With Bedrock, originally, when they first released it, I didn't think you could do any of the OpenAI models, but I think now they also allow you to do the OpenAI models, but just about every other model will be in there. And what it allows you to do is to send your data to AWS, who are hosting a version of this model, the frontier model, and the data loop stays within the AWS environment. It never gets sent off to, in the case of Anthropic or OpenAI, it never gets sent off to the actual AI providers. It stays in either Amazon or Microsoft's data boundary. Now, you may say, well, what's the difference between that and giving that data off to OpenAI anyway, or Anthropic anyway? The difference is almost everyone already trusts Amazon and Microsoft with their data. I mean, if you're using SharePoint, if you're using Teams, if you're using AWS for your cloud environments, you're already sending, and actually most companies have already got a risk assessment and they have risk accepted the idea of sending data off to those. And they don't do it lightly. They're just going to add another one that's going to have access to all of their corporate data. So what these allow you to do is you can keep it in an existing data boundary, which is good. You also, because they're designed for enterprise who are concerned about data privacy, there is a lot more control around the data options and data hosting and control that you can put in here. So it's a very worthwhile one to look at. And then you've got this sort of ugly child, which is open source. I mean, very few people I know are doing open source and hosting and running. The reason why is because although you do have complete data privacy with that system, if you're to trust things like DeepSeek, that people, I mean, that's not, I don't have an opinion either way, but I think a lot of people do somehow not trust even open source sometimes. But generally speaking, when it comes to this, you also need to have the technical know-how, how to set it up, how to maintain it, how to train it, how to get it to run into inference. And even if you manage to do all of that, you're probably still nowhere near as performant as the frontier models. So people don't tend to go for it. However, that is the most secure. I've talked about this in there. Okay, autonomous security. So this is the idea. This is everything that is agentic about an agent and everything that isn't the model or the underlying LLM. So this is everything to do with when you're giving autonomy to an agent, how do you do that safely? Now, it's worth starting by saying, and I said this earlier, that no frontier model is jailbreak proof yet. And I don't imagine that will be the case for some time. That's just the nature of natural language processing that we're dealing with right now. So knowing that the technology we're building on top of is inherently insecure to things like prompt injection, then we need to be very careful about how much autonomy and what autonomy we are giving to these systems. So there are some sort of key examples. There's a lot more that you could put on here, but some sort of key examples is the idea of doing human in the loop. So human in the loop is where anything, and the general advice here would be that if it's critical or irreversible, you require a human to approve it before you allow it to take place. Now, I also work with clients who've got a ridiculous amount of AI agents and they have read-only for everything is fine. But if you want to write for your AI agent, then it needs to be human approved. So it's not critical or irreversible. It's any write action. But these are guys who are dealing with hundreds of AI agents in production. And now they've got the opposite problem of they've got human in the loop, which is now almost someone's full-time job just to approve all of those human in the loops. So there's some sort of risk management approach that is more acceptable here. But generally speaking, the idea of requiring human approval for certain actions is very important. Now, guardrails here are not being used in the context of guardrails that they've become popularly known with around input and output filtering guardrails, but actually talking about the wider sense of the word, guardrails that you can put around an AI agent to make it more secure in its behavior. So, for example, this is the kind of thing that I'm working with startups on at the moment, is like, what tools can your AI agent access? Is that restricted to only the tools that it needs to have for its certain role? With regards to those tools, can it only access the systems and the services that it needs to access? Because a lot of the time, what we've unfortunately done with the AI era is all of the basic security has been forgotten about. I mean, most of the time when I'm prompt injecting and working around these AI systems, you're talking about, I'm assuming people here now have some degree of like web app hacking knowledge as well. You're talking about like really basic IDORs that have like chat history ID that you just change the ID and then suddenly you've got access to other people's chat histories. It's like, we've not been making these mistakes for 10 years. And now in the AI era, we're just scrambling to just push more code out. And we've just completely forgotten about that. Similarly, access control and limited tool access are another ones that in the agentic era, which typically aren't doing particularly well. Role management, this is a real sort of, ant's nest. How do you do identities for your agents? How do you ensure that they have restrictive permissions? That's an area which I'm really excited about for the future and for my own kind of company. But that area in particular is like, generally we want to make sure that the permissions and the access that our agents have and the permissions and roles which they are using and the identities that they are using, let's say to interact with cloud services or whatever, are in line with what that AI agent should require and needs to do its job and no more. Fail safe. So if something goes bang in the night, what happens? Does it fail over to something that we doesn't give us cause for concern, or does everything come burning down and everything grinds to the halt? And then kill switches. If you find one of your agents is doing something you don't expect, if it's looping, infinitely and you can't stop it, how do you turn it off? That's another thing which we need to think about when it comes to how we do AI securely. Also, utility-based agents. So this is an interesting one where it came from some of the original research into, well, not research, but like actually the original kind of trials and tribulations of using AI. And what they found is that if you give AI a superficial goal, then it will find ways to what we call reward hack. So it will find shortcuts around what you've actually intended for it to do. And the best example of this is there was a boat game where you had to collect, you have to go around and win. You basically won the game by completing the race and getting the most points. When they gave it to an AI to try to compete in the game and expecting it to get very good at driving around the track in a very quick way, what it actually found is that if it just did donuts in the harbor and hit all of the walls, it got more points than if it went through the track. And so all it did was just do donuts and it beat the game that way. That's a perfect example of when you use reward hacking and it can go wrong. So that's a superficial goal-based agent will do something like that. A utility-based agent is something that will have one set of conditions which it thinks is important, but it also have additional criteria which it needs to measure every action against. And so giving it the ability to compare and contrast these things, but also keeping in mind, the good example of this is like when they had drones that were looking to fly and do delivery drops around cities, and they found that if you get it to get there as quick as possible, it will fly a direct route. But that means that it may fly through heavy traffic areas, it may fly through storms, it may fly through whatever. A utility-based agent will allow you to sort of consider things like safety and the likelihood of the actual drone getting targeted or whatever it may be. So the general advice: start small, single tool, minimal impact, expand cautiously. And then when it comes to multi-agent systems, there's a lot more that you need to be looking at into and around, like secure communication, handoffs, and then scopes of authority. It's a pretty complex environment, but it's an exciting one, and it's very much expanding and growing at the moment. Okay, the next one is monitoring and red teaming. Now, this is one which is very close to my heart because this is what Secure Agentics that we are focusing on. This is the area of agentic security which we are leaning into. And actually what we're building right now is Adrian, which is a monitoring and control toolkit, which wraps around your agents and makes sure that they're not doing things that they shouldn't be doing. The general sort of high level here that we're talking about is that we want to have, some key sort of monitoring things. The main sort of takeaway from this is if something goes wrong and you cause a breach or there's an incident or whatever it may be, something goes wrong, are you able to point to somewhere and say, okay, this is what happened and this is where it went wrong and this is what happened afterwards and this is the data that was affected and this is the clients that were affected? A lot of the time, in the haste to adopt AI, and even I was chatting to a startup last week actually who is using LangChain, which is the most common framework for building with AI agents. And the question of monitoring and observability came up, and the head developer was sort of like, we've not done that yet. And I was like, okay. I was like, did you know that with LangChain, you can use Langsmith, which is the built-in monitoring and observability function? And they're like, okay, well, that sounds like something we could turn on. And that's something that they turned on like the next day. And suddenly they've got a data trail, they've got an audit trail. If they needed to do forensics for God forbid something goes wrong and there's, an incident and you need to do some form of monitoring or incident response, then they've actually got something to go and look at now. So monitoring, as ever, is more important. This is also, almost everything in this is being called out in compliance requirements, but monitoring certainly is ubiquitously called out in all best practice, compliance, governance, everything, as like, you need to be doing this. That's why we're very excited about what we're building, which essentially looks at what an agent is doing, but also what an agent is thinking in real time to say, is this agent about to do something which is malicious? So I'll talk about that a little bit more at the end, but super exciting space for us. Finally, adversarial testing, as ever, with anything potentially difficult cyber. Number one on my list, I actually posted this on LinkedIn the other day. It was like, now that I'm in the driving seat for product development, what are like the 10 things? In fact, I think it was 12 that I listed were like number one on my list of things to do in terms of secure development. And the first one was around adversarial testing and getting pen testing in, because nothing replaces manual validation of that. So understanding that whether it's on a quarterly basis or however it looks, getting some form of testing done. Okay, number 4. I'm going to have a little sip of this. Okay, number 4 is supply chain, is the S in DAMSIC. This is supply chain and SBOM. Again, this is nothing new. This is not the first time you'll have heard about supply chain risk or about doing things like SBOM. But what essentially the takeaway from this is that AI systems have evolved and matured, and we're now using a system which is actually myriad different systems, versions, models, libraries, packages. And what we're seeing, especially in the recent times, if you think of like all the stuff that's been happening with NPM recently, is that we're seeing a lot more of the attack on the supply chain. And actually what we need is, as ever with anything in security, not just AI, if we see a breach or hear about a breach that comes out and it's big and a sweeping breach across major AI technologies, are we affected? What version are we running and are we affected? Within that, you've also got things like, if you can take it to the next step and get like a SALSA, which basically does like artifact checking to make sure that you don't do updates unless it's manually approved and your updates are signed and hashed and verified prior to them going live, things like that. Finally, as well, manual fallback. So Supply chain is not only here in the fact that supply chain could be the breach. I mean, we already talked earlier about one of the supply chain breaches with Amazon Q, where it's pushed into a supply chain, pushed into a malicious update that gets federated out to all users, however many thousands of users they've got, and then that's being used as the sort of the risk. But also, if your favorite AI provider goes down overnight, do you have a fallback? Do you have a backup option that's going to keep your system running and moving, or are you at sort of a bottleneck for that? Okay, nearly there. Last two. This one is model integrity. This is the I, and this is everything. I mentioned earlier that the A was everything agentic. The I, model integrity, is everything which is LLM, or the traditional, let's say, AI approach. So these things are not specific to agents, but they are just as important in the agentic era, so they still need to be in consideration when you're talking about agentic security. And there's a long list here. I will say that there's no one I know, full stop, who's doing all of these things. I can't even, maybe I can name some people who are doing two. I don't even know if that's actually true. Anyway, the idea here about what we want to be doing, first and foremost, is input and output guardrails. So this is making sure everything going into our AI system and everything coming out is in line with what that AI system should be doing and should be processing and should be outputting. This is probably the easiest one to get people going with. This is probably the one that most people know and most people actually are already doing, which is good news. Adaptive lockout. So this is an interesting one because when you look at the way that you exploit prompt injection, in most cases, prompt injection is essentially a numbers game. You produce a data set. In fact, I say that there's a lot of the systems that I've tested that you can just do it manually, so you don't even need to do this necessarily. But in most scenarios, you create a data set of X number of 100 or even 1,000 of different malicious prompts, and then you just fire it. And you can do it fast, you can do it low and slow, however it is. Eventually, you will find, and I promise you this is true, you will find a combination of whether it's the malicious jailbreak instruction, the base document, the action that you're getting it to do, whatever it may be, there will be a chink in the armor where you're suddenly able to prompt inject that system. The question is, why are we letting people send hundreds or even thousands of clearly prompt injection attack payloads to our system? And so the idea is, well, why don't we do something that's adaptive in that if someone's doing hundreds of requests, full stop, that's fine. But actually, if you can look at the nature of what they're doing and you can see that it's clearly malicious, why are we allowing them to do hundreds of different requests before we block them? So adaptive lockout is another one. Hashed and signed training data. So this is the idea that when you're using what we call RAG or retrieval augmented generation databases, which is where you provide additional information for your AI system to pull upon. So the best example of that is like a FAQs database for your company for a customer service chatbot, right? It can pull upon those. If you're able to, as the attacker, write to that database and poison that data, then that data is then getting pulled by the AI system. So making sure that any tampering of that data set is robust. Secure memory and state management. This is probably the most airy-fairy of the lot because it's actually so new. Like the idea of AI agents going from state to state to state. There's actually something really interesting in that I'm thinking about down the line. Is like, if you found an agent was doing something malicious, could you revert its state, like roll it back in its own sort of state management to think that it was like 3 or 4 steps previous, and then put in a guardrail to say, and don't do what it was that you were doing before I rolled you back? That's a really interesting philosophical, almost sort of security question. Secure authentication and authorization. We're having a chat earlier about this, around how the first version of MCP launched without authentication, full stop. Mental. It's like remote code execution across the web. And they were like, yeah, we don't need to put any authentication on that. So we're seeing a lot of like the old habits creep back into AI. Autonomous action verification, anti-automation, similar to adaptive lockout, and then prompt engineering. A good system prompt can go a long way in terms of restricting what, like, for example, only respond to tasks which are in line with your use case, and you define the use case. Only respond to questions that are written in English or French, for example. And the reason why, by the way, you want to do, and actually I should put that as a separate point, approved languages, only approving or only interacting with certain languages, is because there's a lot of languages which do not appear in training data sets across the internet. So, for example, Zulu is a language which is very rarely spoken and written, and yet AI systems understand Zulu if you speak it to them. However, all of the guardrails and the training which has been baked into the AI systems has been trained on what malicious looks like in English or French, for example. And actually, if you try something which has been like blatantly malicious, but it's written in Zulu, then they're actually not as quick to detect those. Finally, we have compliance. Now, the general takeaway from this is that compliance is not quite here yet in the UK. There is going to be a lot coming around the corner when we see the EU AI Act coming in, and then the UK will copy a version of that naturally. ISO, that's obviously voluntary, but people are going for it more. The Department for Science, Innovation and Technology's Code of Practice is currently voluntary, but again, similarly to how the sort of pattern, that the way that they do things is they release a voluntary code of practice and then it flips over to mandatory for all of UK Gov. Essentially, at this stage, what it's worth doing is, I've already laid it out for you here in DAMSIC, so you don't really need to do it. But think about compliance now, because when it comes on, you don't want to be caught out. And if you can, and this is something that I'm getting my clients to do, build with compliance in mind from day one so it doesn't become such a big pain. And that is everything. Thank you very much for having me, everyone. This is my email if everyone wants to get in touch. Thank you. The other thing to mention is that this is my LinkedIn. I post on there all the time if people are interested. Go to the newsletter. And finally, I'm going through fundraising for the business at the moment. If anyone is interested, I've got potential spots. I don't know, this is less of the sort of developer crowd and more of the attacker crowd. But if people are interested in the product development side of things, I've got space for some more product developers. And also, if people are interested in the design partner phase, then by all means, please reach out and or sign up here. But yeah, that's it. Thank you very much.